webinar series. This is the third webinar of FHWA's Pavement webinar series, and we're going to have 3 presentations today. One on pavement preservation, one on an update from the FHWA Long-Term Pavement Performance Program, and one on pavement safety. Next slide, Amanda. Before we get started, I would like to just introduce you guys to the webinar series, as well as spend some brief time going over our meeting platform, MS Teams. For those of you who do not know me already, my name is Heather Dilla, and I'm one of your moderators today. I am part of the FHWA's headquarters Office of Pre-Construction, Construction, and Pavements team. So, and in this role, I am the Sustainable Pavements Engineer, and where I'm responsible of the pavement design policy and tools such as lifecycle cost analysis or lifecycle assessment, or how we incorporate resiliency to inform our pavement design. In addition, I have Jen Albert on helping me moderate today's session, and she is a pavement and materials engineer with FHWA Resource Center. She has a background in pavement design and pavement management and works in the area of the pavement design policy with me. So since January 2019, both Jen and I have been reviewing our pavement design policy, which included an effort of hosting 5 peer exchanges where we had state agency representatives as well as FHWA division office representatives together to discuss the state of practice of pavement design and challenges or barriers of designing pavements. And from these events, we received feedback on various topics, and the topics that are discussed and organized in the webinar series this year are all topics that came up where participants were interested in learning more. So we thought it was worthwhile to communicate back to you all in these particular areas of interest on what are some of the ongoing efforts. And so that was how this webinar series was developed. With regards to the webinar series, please don't hesitate to contact either Jen or myself. Our email addresses are here if you have any questions or you missed a session, etc. Next slide, Amanda. With that, Amanda's going to briefly go over the MS Teams with you all, and then we'll get started.
Thank you very much, Heather. I'm Amanda McQueen, a contractor on the Office of Infrastructure Mission Support Team. Some of you may have seen my name as we're all learning together how to work really well in this virtual environment, and particularly with Microsoft Teams, which we're using today. So here's just a quick overview for those who haven't used this platform before. You have your toolbar, which may be in the center of your, or a little lower than the center of your screen, that you can hover over. It's sort of like a genie bar. That will allow you to mute your camera, mute your microphone, raise your hand, or show the conversation, or use the chat pod function. Please feel free to use that. For those who have the more updated Microsoft Teams application, this genie bar may be toward the top of your screen. But please feel free to utilize these functions. I know that sometimes we forget to mute and unmute as needed, so it's really great to have folks. Please feel free to reach out or to say something in the chat pod, as you already have, to let us know if something needs to change. But please do keep yourself on mute until the question and answer session, for which each individual will be called on. Here's some brief best practices. Again, for the Q&A, a great place to ask questions to be saved for the Q&A session after each presentation is to put those questions in the chat pod. If you do want to signal somebody specifically, you can use an @ sign and start typing in the person's name. You can also use the hand raise function, and Jen Albert will be moderating that Q&A session, so we'll be able to get to everyone as we have time. If you have any connectivity or any sort of issues with seeing something on the screen, hearing something, feel free to log out and log back in, as this is sort of a streaming service, this platform is. So if not everything is loading, you may just need to refresh your browser or log back in and out using your Teams application. You can also share any issues in the chat pod. If you're using a browser, please feel free to utilize Google Chrome, Microsoft Edge, or Firefox. I'd suggest if you're having issues, just copy the link and jump into another browser. You can also use your smartphone to share the meeting link over email and open it up as sort of a secondary computer if you need to use cell service. If you do have any questions that you just can't seem to get answered, feel free to email me. I'll be monitoring my email throughout this webinar, and we'll get you on board. We are recording this presentation for our internal purposes, and we'll be able to share that individually if you do need to review it later on. I believe that's everything. Back to you, Heather.
Thank you, Jen. So with that, I would like to introduce our speakers today. Let me turn my camera, and can our speakers come forward and turn on the camera when you are called so I can give you a brief introduction. So our first speaker will be Tom Van. Thomas Van is a pavement preservation program manager, and he's been with FHWA for the past 25 years. Mostly in the Office of Infrastructure and on the same team as myself. He's a registered civil engineer in 3 states and holds a master's degree in civil engineering from Virginia Tech and has over 20 years of experience in addition to his experience at FHWA with county and local governments. His primary work areas are in the pavements with materials, pavement management, asset management, preservation, and transportation performance. Next up, we'll have Larry Weiser. Larry Weiser, since 1999, has worked as a highway research engineer for the LTPP program within the Office of Infrastructure Research and Development at Turner Fairbank Highway Research Center. As a member of the long-term infrastructure performance team, he manages and leads a coordinated program of LTPP data analysis addressing pavement research needs of national interest. Larry also oversees the LTPP program areas of surface characteristics and profile data collection and analysis. Previously, Larry worked as a highway engineer for the Office of Federal Lands Highway, developing pavement management systems, designing and building roads and bridges. And then lastly, we will have Andy Mergenmeyer, who is a senior pavement and materials engineer with the Resource Center. He is a field project engineer for the FHWA Friction Management Program project that is the basis for much of the information that will be discussed today in his presentation. For the past 10 years, his work has focused on pavement surface characteristics, measurements, and analysis. He came into this position in 2007 years as a state materials engineer for the Virginia Department of Transportation. Before VDOT, Mr. Mergenmeyer worked for FHWA for 15 years in various locations throughout the U.S. Mr. Mergenmeyer is a civil engineering graduate from the University of Kansas and a registered professional engineer. With that, we'll turn it over to our first speaker, Tom.
Okay, I hope you can see me here. I know I'm having some difficulties here today. Let me pull up my presentation here. If I can make this work. Maybe I can't. Let's see, share the screen. There we go. Let me get to the full thing here.
Yes, Tom, it's up, so we can see it.
Okay. Okay. By way of introduction, you heard Heather, who gave you my whole biography or obituary or whatever it was. As you can see, I was with Federal Highway for about 25 years. Worked in a lot of different areas. Preservation has always been a very important part of what I've been doing. In addition to that, I've been a sustainability ambassador for some time now as well. So today I'm going to talk a little bit about the Pavement Preservation Strategic Plan. It all starts a little bit with the definition. A lot of folks have struggled with this. We need to try to connect this to our TAMP and to our work types, our investment strategies, a lot of that activity. We're trying to link it to target setting and TPM. We always have funding issues. We try to deal with some of those, and we're trying to focus a lot of our attention now on fitting it into the larger program and at the same time keeping our key project level considerations. As we move in here, it's important to link together with a lot of the different programs. So if we talk a little bit about why we want to do that, I mean, part of it is having to do with connectivity and continuity in our program, because continuity, results in a certain amount of effectiveness and continuation of dollars. It's also a little bit about transparency and the accountability for the program. If you step back a little bit, you also have to be able to think a little bit about, well, what is it that we're doing? Is it working? Are we making a difference in that? And you can see on the screen here now, we also have some strategic objectives in how we're going to try to go about doing that with the pavement preservation program. So if the programs are linked, then what's the role that Federal Highway has to do in this? Or just how do we go about, how do we see our role in how we do this? And you can see here we have three major areas where we try to make a little bit of a difference in the programs. We have a highly qualified team out there. We've been around this stuff for a long, long time. We're trying to do some national awareness and put some connections together. We have some agency resources and some capabilities, particularly in the areas of research and development of programs with that. So if we think a little bit about our national connections in this, what kind of folks are we dealing with? Of course, we deal with the states a lot. There are definite partners with this. We're directly working with them. We do participate with these other groups as well. And you can see in here that we have a number of government groups in here. We have industry organizations, a large number of them. And we have some academic organizations on it. We try to participate in all these programs as much as we can and try to make a difference in the whole program that everyone is doing. So as part of that, we try to then refocus some of our efforts. And in this past year, we've developed a technical feedback group there, which is trying to focus some of those efforts on some of the key challenges and opportunities that we have. These folks in this technical feedback group, these are the movers and shakers for the pavement preservation programs. That also gives us a little bit of a reality check to make sure that our programs are in fact reaching the folks that we need and doing the things that we think that they're doing. So let's talk a little bit about what's in the 2021 program on that. Some of it's carryover, and you can see on the screen here a number of the things that we're trying to do with it. It's more formalized than it has been in the past, but we're hoping to get a lot more resources going into it as well. So a key part of this program is making the program grow. And that's part of why we have a strategic plan. It formalizes the program, gives us some missions, some objectives on it. It allows us to collect thoughts and get some needs together, identifies, formalizes a process that we can move forward and make something of a difference. And it benchmarks our progress on these programs, tells us a little bit about where we are, where we need to go with it. We have basically, in the coming year, 3 major strategies on it. First, we need to get a solid foundation, take stock of who's doing what's getting in the way, what sort of available resources we have, where are they, who's got them on it. We need to increase our understanding on that. Updating our website is one of those items in it. Publishing some of our things that are in it. The second strategy is encouraging the programs on it. And we can do that by making tools available. We can do that by trying to expand the community. If preservation is about sustaining pavements, we need to get everyone involved in this. We need to look at innovation. You know, what's new? How can we better use some of the existing techniques that are out there? And we need to connect people together. That means connecting industry, connecting the states, connecting the academics, showcase some of the great things that we're really doing with it. You know. So the third strategy then is a little bit of research and development. This has been set aside for really too long. You know, there's a lot of new materials out there. There's a lot of new processes out there. You know, we need to take some dollars and some resources to prove, you know, when can we use these things? When do we not want to use some of these things? What to expect as a result? And get some more of this information into the mainstream. So if we're really going to make a difference, we need to have some objectives, some targets that are out there. And you can see on the screen here some of the ones that we have. The chart has our targets on that, showing the accountability that we're doing and some of our expectations for the outcomes. While these may be interesting to all of you, our management is kind of holding us to being able to accomplish these things. So we do encourage you to help us and to help us be successful in making these things happen. So what are some of the next steps? Well, we want to publish this plan. It's still in the review process right now. It should be approved very soon on there. We want to implement it as we get started in here. We're going to constantly look for some more opportunities with it. So we have the team here, and you can see our team that we have available here. Got some contact information. You'll get a copy of this eventually here, so you can definitely reach all of us on it. And just to give the last plug in here, our esteemed leader, LaToya Johnson, who's been leading us to go that direction on there. And so that's about it. So thank you very much.
So thank you very much, Tom. We're just going to take a quick pause and see if anybody has any questions. You do have a couple options. You can unmute yourself and ask a question verbally, or you can type a question in the chat pod. And I just want to take a quick second to check in on Craig Landfeld. I see that your hand is raised. I'm not sure if you're wanting to ask a question or if that's an accident, so feel free to speak up if you have a question. And Tom, at this time, I don't see any questions in the chat pod and no other hands raised. So I think we can move on to our next speaker at this time. Larry?
Yes, hello.
Yes. Okay.
I'm going to pull up my screen. Hopefully everyone can see that.
Yes, we can see it.
Okay. Hello, everyone. My name is Larry Weiser, and today I'd like to provide you with an update on the long-term pavement performance program. And in doing so, I'm going to provide an overview of the web portal and an introduction to the data analysis plan. Starting with the overview of the web portal, specifically, I'm going to talk about the LTPP Infopave site and show you the LTPP section mapping, how to select and download LTPP data, data availability chart for the program data, and also show you the Transverse profile viewer, which was something that we released in 2019. So in doing that, I'm going to go over to the web page, and hopefully that came up. And if you go to LTPP Infopave, you'll come in on the home page, but if you go over to visualization, there's a section in mapping area. And what I have highlighted here to start with is there's 2,581 sections that we've monitored over the past 30 years. And we've been monitoring them throughout North America, including Puerto Rico and Hawaii, as you can see here on the map. To get a sense of some of the data, or the data that's available, or what we monitor on those sections, we go over to the data selection and download in the data hub, and on the visualization selection for pavement structure and construction. Here you can see some of the things that we have collected or monitored for all the sites. And we also have the climate data, and this is data we've collected and is available for download here on Infopave, as well as the traffic monitoring data that we have, and lastly, the performance monitoring that we've conducted in the field over time. To kind of give you a sense of how much data is actually available for some of these things, or I guess before I do that, if you go to the tabular section, then you can see the for pavement and construction data, all the information that's been collected on pavement thickness, material features, and pavement maintenance and rehabilitation. As for the climate, we can also look at, we have MIRA, virtual weather station, automated weather station data, and information and data from the seasonal monitoring program. Under the traffic data, then this is the monitored data that we've been collecting and the states have been submitting from the beginning of the program. And finally, under the performance monitoring, we have the distress, surface characteristics, back calculation, and dynamic load response information. So if the interest is in longitudinal profile data and you wanted to look at the section level IRIs, these are all the data fields that are available for download. Maybe you want to look at the elevation measurements and the 25 millimeter profile elevations, then could be downloaded by hitting the add to selection. And then at the top of the page, if you go to the data bucket, you can retrieve your data or submit it for an email back. Now to move on to looking at some of what all is kind of available within the program. Under the analysis tab, there's a data availability chart. And when you go there, the wheel comes up and it shows you for all 2,500 plus sections, how many surface types we've collected data on, as well as many other elements that within the program, such as longitudinal profile again. And here, when you hover over it, it gives you average and maximum number of field visits, as is the same for like transverse profile. Now to talk about the transverse profile viewer, just to give you a sense of some of the visualization that's available on the website. Here you go to transverse profile viewer. You can pick a state and a section, a survey date, and select a 10-meter interval that you would like to look at. And when you do that, you get a downward facing camera. And the top image is the range view. The bottom image is the intensity view. Scrolling down further, you get the forward facing camera, which gives you a sense of where you are along the section. And then at the bottom, you have the left and right half normalized elevations that you can toggle on and off. And at the very bottom, you get left and right half lane rut depths for both the straight edge and the wire reference. And so next, I guess what I wanted to touch upon is the additions to the web portal for non-LTPP data on Infopave, and specifically the Min-Road test track data and the Federal Highway Info Materials site. Going back then to the web, if you go to the non-LTPP tab and select Min-Road, then this will come up. And first off, you get an overview of MnRoad, which is a pavement test track made up of various research materials and pavements owned and operated by the Minnesota Department of Transportation. And like Federal Highway, MnDOT developed the Pavement Performance Database to help advance knowledge in pavement engineering. If you go to section selection, similar to what you can do on with the LTPP data, you can pick a particular section, individual section of interest. And again, this serves as an example of other pavement performance monitoring data being available to the public. And then, similar to the LTPP data, you have a data availability wheel, and then you can come down here and see the wheel. And for the 764 sections at MnRoad, you can get a sense of how many are rigid or flexible and so on. So the non-LTPP hub has served as, it represents a continuing objective of the LTPP program to include data sets that complement and enhance the understanding of pavement performance. And to further that, I'm going to talk about the Federal Highway info materials. When you click on the info materials, you end up coming to this, which is live on the web right now. And Info Materials is a user-friendly, centralized gateway to access and visualize Federal Highway data from across Federal Highway on infrastructure research and materials testing. And this was first released in January of 2020. The benefits of Info Materials is accessibility and transparency of Federal Highway research and material testing data, enhanced organization and functionality, minimize duplication of research and material testing, and it also facilitates data sharing and cooperation among research programs and agencies. These the data sets that are shown here provide direct access to asphalt, concrete, material characterization data, as well as pavement performance testing and analysis results, and many other types of data. With the 3 that are here, more data is being added, and also 5 additional data sets, including maps and graphs, will be released in January 2021 at the TRB annual meeting virtual booth. So I encourage you all to check it out then. But in selecting one of the data sets, you can hit the about and get background information on a particular study, as well as where some of the data has been collected. And then under the references, it provides all the relevant references to specifications for this study, as well as chapters, journals, and other publications that were relevant to the study, as I said. As in the LTPP data, you can always filter data over here, such as for info materials, selecting test method. You could select just a particular test of interest and look at that data set individually. Or you could just go to the data for the data set and say you want to look at mixture design, mixture aggregate gradations, and you could come over here and see the fields that are in that data set. You can preview that data set to get a sense of what you're looking at and how much will be downloaded. And by clicking the download, you could then get the data either in Access or Excel. So next, what I'd like to do is talk about give you an introduction to the data analysis plan. And in doing so, I'm going to talk about the plan itself, how it's been expanded over the years, where it is and what it looks like in a little bit more detail on Infopave, and then touch on some revisions that will be forthcoming for the data analysis objectives and outcomes. So a plan was developed in the late 90s and for using LTPP data to develop knowledge, relationships, and models to facilitate improved pavement design and reliable performance predictions. So there was a purpose and a goal and expectations set out at that time, as well as 7 original objectives, which I know you can't see, but I kind of have highlighted here. So originally the plan looked like this, and across the top are the 7 objectives in the gold or yellow boxes. Underneath each objective is a supporting outcome. And then there are projects and studies that fall under those outcomes to help support the outcome, which then helps to successfully complete the objective of the program. And these objectives were based upon the original SHARP LTPP studies. So this plan has been a living document and has been revised and updated regularly since its adoption to show the status of the analysis projects. And new projects have been added as more and more data has become available within the program. To get a sense of how it's expanded to date, I'm bringing this up just as a visual to show how many projects we've actually added or how many ideas we had as of last year. And as these workshops were held over the years, as I said, things have been added and removed based on relevance. And in 2010, we added objectives 8 and 9 to this data set, or to the plan. To look a little closer at the plan itself, we can go over to Infopave and go to the analysis and LTPP data analysis plan. And here on this page, you can see the 9 objectives that were on the screen before that you may not have been able to read. But I guess at the top, there's 220 different project ideas and 109 of those have been completed to date. So to look at some of the objectives a little bit more in depth, if you click on materials characterization, you see the underlying outcomes for material characterization. And then if we open up one of the outcomes, you'll see the supporting projects underneath. There's various colors on these boxes, and the blue and pink are NCHRP projects that are directly associated with these LTPP outcomes and objectives. The gold boxes are projects that have been completed by Federal Highway, and they're finished, and there are reports available for download on this site. And the white boxes are projects that have not yet been initiated, but are on this plan as a placeholder. So because there's so many projects and it's been a little while since we did a workshop, we met with our long-term infrastructure performance pavements ETG expert task group in April and started to discuss preparations for a data analysis workshop. And that was followed by a series of planning meetings, which resulted in revising these current 9 outcomes. And what ended up happening is we came up with 5 draft or revised new objectives. And as I'm kind of highlighting here, of those 9, the past 1, 2, and 3 objectives have been rolled up into just a single number 1 objective moving forward. As a result, we needed to update these outcomes and revise those to make it so that everything kind of fits together and it is relevant to today. So these revised outcomes, as a result, will be updated in the coming months and put on Infopave. Right now, these just kind of stand as draft. And as I mentioned, we planned the workshop and we conducted a workshop using virtual meetings held on 6 separate days at the beginning of November. We had over 40 subject matter experts from the Expert Task Group, Federal Highway, and other state highway agencies. And as part of that workshop, the goal was to update the analysis plan to reflect a strategic approach to using LTPP data to meet the highest priority needs of the pavement community. The purpose was to receive input from subject matter experts to be considered by Federal Highway in revising the plan, and the products of the workshop were to assemble a set of proposed new and revised project descriptions that outline the required work for the LTPP program. As a result of this workshop, we received over 25 problem statements for consideration, ideas for future statements, and revisions to those objectives and outcomes that we will eventually get onto Infopave. So in closing, the LTPP Long-Term Pavement Performance Program has made significant progress over the years. Much remains to be done, and coordination, of course, is essential with other programs, much as the same as what Tom mentioned. So with that, that's the end of my presentation. So I'll turn it back to you, Jen.
Yep, sure. Thanks very much, Larry. I had a comment and a question. Incredibly powerful database and interface, terrific resource for researchers. That was the comment, and then a question. For someone who is not engaged in research directly or on a daily basis, this resource can be a bit overwhelming. Do you have some introductory training guides to help people become familiar with how to use this resource?
That's a great question. Thank you, Life. And with the TRB virtual booth, we have revised and updated our introduction videos. They're about 5 to 6 minutes long. One for LTPP Infopave, one for Info Materials, and we also are going to have one from our team for LTBP, the bridge program, Info Bridge. So that'll be part of our virtual booth at TRB, and then they'll be posted. And this is all going to be released live too on the webpage when you go to Infopave or whatever. So there are some other resources there, some introductory videos for the different hubs that can be accessed under the help menu. So please feel free to go and explore.
Very good, thanks. Any other questions from anyone? I would also note that Sharon Sneed did post a link to the Infopave website. So there's a link in the chat pod if anyone's interested in that. I don't see any additional questions or hands raised at this time. So with that, thank you very much, Larry, and we can move to our next speaker, Andy. Mr. Mergenmeyer.
All right, Jen, please let me know whenever you can see my presentation. And can you hear me okay?
Yes, I can hear you. And yes, I can see your presentation.
All right, very good. Thanks a lot. I appreciate that. So the audience here is pavement and materials engineering, so I'm going to do my best to try to provide information related to safety, performance, modeling, and analysis that the safety folks conduct and how pavement friction can flow into those models. Whenever I was the state materials engineer with Virginia DOT, I was not aware of safety analysis modeling. So over the past 10 years, I've been working with Federal Highway's Office of Safety on various pavement and safety related efforts, for example, rumble strips and high friction surface treatment. So they've done a pretty good job of educating me on some of the safety performance modeling and analysis processes that they use. And with that, I have a better idea of what type of data they need from us. One of the key things, anytime you have someone conducting an analysis and another party providing data to support that, both parties need to understand each other's needs. I go back to my days with the state DOT, and if you have a drill crew, that drill crew can be doing work for bridge foundations one day and then pavement foundations the next day. And that drill crew needs to understand what the needs are of those different users, because they are significantly different, but all the data comes from one source. It can be challenging to work together whenever you're within the same unit, but whenever you're in different units like safety and pavement folks, it can be even more of a challenge. Like in the area of pavement and materials, we may use friction-related information, and we may use it to get relative comparisons of aggregates and pavement surface textures, but that's not a safety analysis methodology. That's what we do in pavement and materials. So we have to be cognizant that that doesn't directly relate to safety analysis. And then I've met with many safety engineers across the country, and the majority of those do not understand the various attributes of pavement surface characteristics that are of interest to them. The concept of micro and macro texture that we understand. And so we have an effort ongoing there to work with the safety community to make them aware of those attributes. So there's many efforts going on nationally to bring together these two parties. And what like I said, I'm hoping to do today is bring forward some information that will give you an idea of the safety performance modeling and analysis and how we can support that with friction data. So the second part of the presentation, we'll be talking about the friction data to support safety, and then I'll wrap it up with a couple case studies where I do have some friction data to further reinforce that. So anytime we talk about something at a high level within Federal Highway Administration, we first start with our policies. So in the pavement design community, Federal Highway Administration in 23 Code of Federal Regulations 626, we have a very succinct policy. It is very clear. The durable and cost-effective issue, that's something that we as pavement and materials engineers have been focused on continuously. That's generally what we think about mostly, but we also have this other attribute called safety that we need to be cognizant of and support efforts there. So what is the safety community doing? The current Federal Highway Strategic Plan has a goal. The goal is to reduce fatal and serious injuries. Now, the interesting about this, the safety community is changing at this time. I want to highlight here, hopefully you can see my red highlighter underlining systemic safety management approaches. Essentially, the safety community is moving from hotspot-driven analysis to a systemic analysis using network screening approaches. So what a hotspot is, that's where crashes have occurred. That was the backbone for much of the safety efforts over the past 50 years. You have crashes occurring at a location, investigation is done, and then some type of remedial treatment is provided at that location. And what we have found is that that may not be the most cost-effective and efficient way to improve safety. And many times we just move the hotspot location down the road. So now the focus is on systemic safety management. And what that does is that focuses on the probability of crashes occurring driven by local conditions. And one example of that, again, in the pavement arena, is the use of rumble strips. Rumble strips are an example of a systemic approach to reduce fatal and serious injuries. So the Federal Highway Safety Community, they investigated fatal and serious injuries, and they broke up different types of crash types into those that are overrepresented with fatal and serious injuries. And 46% of fatal and serious injuries occur on a crash type called a roadway departure crash. Now, the definition of roadway departure crash is when the vehicle leaves the lane that it is traveling in. Some of us laymen will just talk about lane departure, but it's whenever the vehicle leaves the lane that it is traveling, and that's a roadway departure crash, and that is overrepresented in fatal and serious injuries. Also, you can see that intersection only is 18%, so that is also overrepresented. So those are the crash types that the safety community are focused on to reduce fatal and serious injuries. So do we have any issues related to friction and crashes? Those of us on this call, I believe most of us are all aware of high friction surface treatments. Those are spot applications using manufactured aggregate that has long-lasting and very high friction characteristics. So I'm assuming that we all know what those are. This data here is from Kentucky, which was one of the early adopters of high friction surface treatments. And you can see this is 138 locations. Whenever the safety folks do analysis, they use at least 3 years of before installation crash data and at least 3 years of after installation crash data. So that's what all this data is based on, at least 3 years before and at least 3 years after. And what you can see is that for all the crashes in a wet condition, the crash reduction was 91%, and in a dry condition was 53%. So very clearly, and at these installations, I also want to state that the only treatment done on the roadway was a high friction surface treatment. There were no other treatments to reduce crashes. So it clearly shows that friction was related to the majority of the crashes at these locations. You also see a significant reduction in dry crashes, not just wet crashes. So that's another element that we want to bring forward, that friction may not only be a wet condition issue, it also may play a role in dry crashes. As a side note, there's a 1999 INSHRP report where state DOTs, about 50% of them indicated they do some level of network level friction testing. And as I go around the country and I talk with state DOTs, safety folks, maintenance folks, and materials folks, very few of these high friction surface treatment installations were identified by network level friction testing efforts. And I think that's something that we need to be cognizant of, is our network level efforts. Are they giving us the information we need to improve safety? I want to highlight here that Kentucky does not conduct network level friction testing. They identified all these locations based on crashes, crash attributes, and also roadway geometrics. So let's get into more on the specifics of safety analysis and modeling. So looking at network screening, again, this is that concept of a systemic analysis. They objectively analyze various attributes, crash history, roadway factors, and traffic characteristics. They do this modeling to help identify and prioritize locations for potential safety investment. The safety community, they very heavily use cost-benefit analysis. And the cost is usually the traditional cost that we think of, construction cost, and the benefit are the expected reduction in crashes based on the safety improvement. So how did they come up with those? Well, they have a modeling approach. I don't expect you to read the cells on this slide here, but what I want to point out is this slide is from the AASHTO Highway Safety Manual. So again, this is a nationally recognized modeling effort. And I want you to just look on the left-hand column, and you will see that they have safety performance models for various highway classes. And so you see at the top here, where my highlighter is, we have rural two-lane highways. And then the lighter green, we have rural multi-lane highways. Then the light purple is urban and suburban arterials. And at the bottom, we have freeways and interchanges. So they have different models for different roadway classifications. Now let's jump in and let's take a little bit of a deeper look at these safety performance models. And we're going to look at the rural two-lane highways because whenever I think about the installations of high friction surface treatments, I think they're predominantly on this network here in the US. So this is a national modeling approach. And so one way that we can think of it as pavement designers is we have the Mechanistic Empirical Pavement Design Guide, MEPDG. So this is similar to that. We have national models, and many agencies have gone to local calibration in the MEPDG, and it's the same in the safety community. They've done local calibration to improve the model resiliency, the model reliance within their state. So let's look at the base equation for the model for a rural two-lane segment. We have on the left hand of the equation, we have which is the crash frequency. And we always have ADT and we have the segment length. So ADT, traffic, and the segment length, which can vary based on the analysis being conducted. So that's always one thing that the safety folks have to look at is what is the appropriate segment length for this analysis? And I'm going to touch on that as it relates to friction. And then you have all these other attributes here, and CMF stands for crash modification factor. And if you look up here where my highlighter is, you can see that you have different roadway attributes that they develop crash modifications for. In this first cell, they have horizontal alignment. So there you have the horizontal curvature and super elevation. Next, you have vertical grade, so vertical alignment. You have lane width being an attribute that will impact the safety performance. Shoulder width, whether it's paved or not, whether or not you have a shoulder. So there are many roadway attributes here that nationally crash modification factors have been developed. So again, I think the easy way to think about it from a pavement perspective is this is the national MEPDG for safety performance modeling. All right, let's go in and let's do one simple example of how this works. So you have a roadway designer who has a rule 2-lane segment, and the base condition for lane width is 12 foot. And so this designer is looking at what is the safety performance if I go from the base condition of 12 foot and I go to a condition of 11 foot. So the base condition is 12 foot lane width, crash modification is 1, and the analysis is if we go with 11 foot, what is the impact on safety performance? So nationally, the crash modification factor is broken up into ADT less than 400, where the crash modification is 1.01. So in other words, if you go from a 12-foot lane to an 11-foot lane on a 2-lane segment with the ADT less than 400, the crash frequency is expected to increase by 1%. Now, if we go to the next condition, which is if you have the ADT is greater than 2,000, again, going from a 12-foot lane to an 11-foot lane, you have a crash modification factor of 1.05. So you have an expected crash frequency increase by 5%. So that is the approach that the safety community is using right now to get an idea of the crash frequency. All right, so how can that relate to friction data? This is just another way of showing that equation. And what we can do is we have these factors here, friction, macro texture, horizontal curvature, cross slope, vertical grade. All those attributes can play a role in the crash probability. And so they can be included in safety performance functions. They just have not been to date. But if we're going to include them, one of the things we have to look at is what is the appropriate segment length, this L factor? What is the appropriate segment length for friction data in safety performance function analysis? All right, now let's take a look across the pond. Here is a table from the United Kingdom, and they have a chart. And this was not developed based on the models that I just showed you, but the models I showed you could be used to develop a chart like this. All right, so let's go through and see what this friction investigatory level chart is for the UK. What they've done is they've broken down their network into friction demand categories. So what they do is first of all, they recognize that different segments of the road will have a different friction demand. Friction demand is the pavement surface friction that is needed for the vehicle to perform its maneuver safely on that segment of roadway. So if we look at this first one here, motorway, that is essentially the interstate here in the US. Then we go down to C, that is a single carriageway non-event. So that would be a 2-lane 2-way roadway on a tangent section. And you can see across here, you have the different investigatory levels. So in other words, you have 0.3, 0.35. So this is the friction test reading that if you are below, for example, on the motorway tangent section, if you're below 0.3 or 0.35, then you would consider doing an investigation at that location and see if there may be a friction related issue. Now let's go down to S2. That is a bend with a radius less than 500 meters on a single carriageway. So what that means is that is a horizontal curve with a radius of less than 1,600 feet on a two-lane, two-way roadway. And you can see that their friction investigatory level is higher for that segment of road than it is for like the interstate. And if you think about it, it does make sense that you're going to need more friction on the pavement surface for the vehicle to do maneuvers in the two-lane, two-way roadway on a sharp horizontal curve than on a tangent section of interstate. One thing that the safety analysis modeling that's done in the US, not only can you develop a table like this, which maintenance forces could use to help them manage friction, but also the analysis will identify segments which have higher cost-benefit ratios. So it can also be used to look at individual segments, prioritize them for investments. So with that as background on how the safety folks look at safety performance, I'll now go into some of the friction data that is needed to support that. All right, so we go back to our model, and we have again P is the crash frequency, and we have this appropriate segment length that is needed. And here you can see ADT, and then we have the other attributes that we could bring in from the friction side of things. And one thing I want to bring forward now is whenever we talk about pavement surface friction characteristics, we're talking about micro texture and macro texture. You need both of those pavement surface characteristics to give you an idea of the friction characteristics. All right, now let's go and talk a little bit more about what is the appropriate segment length for the analysis whenever we're talking about friction. Whenever we first started talking to the safety engineers who do this analysis, they said traditionally we try to go for as long as segment length as possible because that gives us a more robust data set in looking at crashes. In other words, whenever you go along the roadway, you know, crashes don't occur everywhere. And so the longer the length, the more crashes you have there, and that helps in having a robust data set. So another piece of information that they said is that in all the state DOT safety folks that I've talked to, they said, you know, the crash location data we believe is fairly accurate whenever you're looking at a 0.1 mile segmentation. To go into a shorter segmentation in that, we're not so confident in the accuracy of the data. So what they did is they let me know, wait, hey, how is the crash location defined? So it is defined by law enforcement at a crash site, and law enforcement is different all throughout the country, as you can well imagine, and every jurisdiction may be different. So some have GPS units to help them locate the data or the crash location. Some will use mile points. So you can see you have variability in the location of the crash. And then also that law enforcement official has to figure out, well, where did the vehicle leave the pavement? And so that is not clearly defined. So that's why this concept of, you know, we're fairly confident that if a crash is identified, that it happened somewhere within a 1/10 of a mile range, but we don't have that high of a confidence if you go any shorter than that. So that's one thing they brought forward. So whenever we look at friction, how much does friction vary as you go down the road? Is it something that can be averaged out over a long length, or is it something that we need to look at shorter lengths to give us an idea of friction that impacts crashes? So we have a report from NCHRP in 1967, and it's report number 37. And I'm going to read it to you because I think it's very important. So the first part of the sentence says, because the intensity of polishing process increases markedly with tread element slip. In other words, the polishing action, the forces of the tire, the rubber tire on the pavement surface increases the more the tire slips. So the more it breaks, the more it goes around curves. In other words, where it's not a tangent section. So with all other factors being equal, the lowest friction levels are found on high-speed roads, curves, and approaches to intersections. In short, in locations at which higher friction values are needed the most. So in 1967, it was recognized that the polishing action on high-speed roads at curves and intersections is greater, which will result in less available friction on the pavement surface. And we know that these are high friction demand areas. We know that we need more friction at these locations than we do a tangent section. So this is a very critical piece of information whenever we think about friction and what we need for safety analysis. All right, so let's talk about pavement conditions. We're all pavement engineers and materials engineers on this call. One thing that we've really been focused on as a community over the past 10 years at least is continuously measuring the pavement condition, because we know that many pavement condition attributes change every few feet as you go down the roadway. Look at all the work we're doing in density, intelligent compaction, infrared technology, ground penetrating radar. We know density is very critical to the pavement life, and we know that it varies as you go down the roadway if we don't have high quality construction practices. Look at structural integrity. We're trying to move towards continuous structural integrity measurement with traffic speed deflectometers and ground penetrating radar systems. And then ride quality, that's one that we've been doing for many years. And how do we measure ride, and what do we measure in ride? Well, we measure ride continuously. So let's think about our ride construction specifications that are based on the IRI, the International Roughness Index. One thing we know is that if you have a construction project and your specification averages the IRI over the length of that project, let's say you have a 5-mile project, you know that the averaging of that ride quality data, you lose the ability to find localized roughness. So it's not providing you the information that you need to provide a long-lasting roadway, because we know localized roughness will result in reduced pavement life. And we also know localized roughness impacts the user of the pavement, the tractor trailers, the automobiles. They will feel that localized roughness, and we don't want that to occur. And so what we do is most agencies have a localized roughness specification. It's not just averaging the IRI over the entire length of the process. They also have localized roughness. Now, to get the localized roughness, they measure the ride quality continuously. So that is very similar to what I see in friction, is you need to measure the friction continuously to find those localized lower friction areas, which is what we need for safety performance modeling and analysis. So what do we do in the US? The standard friction testing system out on our highways is a locked wheel skid trailer. The standard test speed is 40 miles per hour, and the wheel is locked up. What you have is a trailered unit, and water is sprayed directly in front of a wheel that is locked up, and the data is taken over 1 second, which means you get 60 feet of pavement surface, which is measured per test with a locked wheel skid trailer at 40 miles per hour. I can tell you that all the data that I've seen with the locked wheel skid trailer, it is a very repeatable test, especially whenever we're doing anything in the field. We know the variability in field conditions and the challenge of doing any field testing. But this is a very repeatable test for that 60 foot. So if you're able to always test that exact same 60-foot tire footprint, you'll have good repeatable test. But unfortunately, it is a sample-based approach. It's not continuous. Okay, I mentioned earlier, what are the surface characteristics of interest to us whenever it comes to friction? It is micro texture and macro texture. So to make sure that we're all on the same page of what that means, here is a pavement cross-section. The dark area here is the binder material in the pavement cross-section. And then we have the aggregate, which is in the binder material. On the surface of the aggregate, we have what is called the micro texture surface characteristics. So if you think about rubbing your hand over a piece of sandpaper, that rough grit, that is what micro texture is. Now the next thing we have is macro texture. And what that is the voids on the pavement surface. Though that void does many things good for us in a friction situation. One of the main things it does is it gives us an area for the moisture to evacuate so that the rubber tire is able to come in contact with the aggregate in the pavement surface to give the friction we need. So macro texture is important for many things. And it is even more important as the speed of the highway facility goes up. Macro texture becomes even more important on higher speed roadways than lower speed roadways. All right, so that's micro texture and macro texture. We need to be measuring those. And the case I'm making is we need to be measuring those continuously down the road for use in safety performance modeling and analysis. Okay, so what are the different test procedures that are available to do this? To the best of my knowledge, for micro texture, again, there is no perfect micro texture test out there. What we do is we have rubber tires that we can apply on the roadway and get an indication of the micro texture. These tests are more sensitive to micro texture than macro texture. So they do give us an indication of the micro texture as you travel down the roadway. And that is a rubber tire test. For macro texture, luckily, we don't have to rely on a rubber tire in contact. There are non-contact sensors that provide us repeatable data related to macro texture. Many of them are laser-based systems. Essentially, if you think about an IRI profiler, one that gives you longitudinal profiles so you can calculate the IRI pavement roughness, most of those measurement systems also can give you macro texture. So the technologies do exist. And again, I want to highlight that there is no perfect test for either of those. They give us an indication of micro texture and macro texture. But as engineers, we know we can't wait for perfection. Okay, so the data that you're going to see is from the micro texture, which I'm going to also use a general term for friction, is from this unit here. And you can see there's a test wheel here. So you have this rubber tire test wheel in contact with the pavement surface. Water is applied directly in front of it. And this test wheel is angled at 20 degrees to the direction of travel. The forces are measured on the hub, and what you get is a side force coefficient of friction from this test result. And it is a free rolling hub, and so the side force is based on the 20-degree angle of that tire to the longitudinal direction. And for the macro texture, we have this laser-based non-contact sensor. Like I said, these are on many of the units that you have at your state DOT right now to give us macro texture information. All right, so let's look at some of this data and see what it can tell us. All right, so my first example is going to be to show you the continuous friction measurement data along with the locked wheel skid trailer, which is discrete measurement data. So we have a graph here. I want you to get familiar with this graph because you're going to see this graph several times with different pieces of data on it. And so on the horizontal axis, that is our distance as you go down the roadway. And you can see here that we have mile markers, 54 to 61. On the left-hand vertical axis, this is our coefficient of friction for various testing systems. The yellow dots here are individual dots. These are the locked wheel skid trailer. And what is used here is a ribbed tire with the locked wheel skid trailer. And the testing was performed at 40 miles per hour. And the blue line is that continuous friction measurement that we got from that continuous friction measuring system that I showed you earlier. On the right-hand side, we have the macro texture, which we're using mean profile depth to characterize the macro texture. Again, I don't want to give anybody the impression that absolutely mean profile depth is the only way or the best way to go, but it is a way to give us an idea of macro texture. So for this case study here, I only want to highlight that as you see the macro texture, you see that the majority of the time it is above 1.0 millimeters. You have a couple areas where it does drop down to about 0.7. I just want you to keep that in the back of your mind whenever we look at some data later on. All right, so let's look back at these yellow dots here. So those of you familiar with the locked wheel skid trailer, using a rib tire, you see the ranges from about 42 to 48. And so you know in your mind what that means from, is that sound like that's a good number or maybe a little bit low number? But what we have is a continuous measurement. You'll see that we have this area here at 59.8 where it looks like we got something going on because the friction is dropping in that location. So we're going to take a look at this location a little bit more in depth. And here it is. If you think back to the discussion about does friction vary, we have an intersection here. We have horizontal curvature and vertical curvature. So we have a lot of vehicle dynamics going on. So I think this is a good example of where the polishing on the pavement surface from the tire interaction has resulted in lower friction in this area. For this state here, in the study that we conducted, we talked with them. We gave them a list of 10 locations that we suggested they go and take a look at and see if maybe they could look at this location and determine if maybe friction was playing a role in some of their crashes, maybe if it's an attribute that we need to take a look at closer. Basically, we just said, hey, go take a look at your data set, maybe go out to the site, whatever you think is appropriate to do an investigation. And so they did that. And what they did is they sent their locked wheel skid trailer out to collect data in that location. So the operator went out, and what we have are additional data points. These red squares are all the additional locked wheel skid trailer data points. There's about 15 of those. So that means the operator drove back and forth across this road many times taking a test. And he was trying to find this area of low friction, but you can see that he didn't do any tests in that location. And it's a real challenge. Any of you who've trailered a boat, you know what it's like trailering a boat. You know how that trailer can move, or anytime you've trailered anything, you know that trailering is different than driving without a trailer. So you got to be cautious, and in particular on curves and such like that. And I think this is a good example that it is challenging to test in these locations with a trailered unit. So let's say, what if that trailer could actually test within that curve? What do you have here? You have 30 feet of continuous friction data averaged, and you can see it's at 50 at the beginning, then we go to 41 and 34.7 in the middle. So even if you could pull a test in this curve, it would be a 60-foot test. So would you be able to pull the test in the location where the low friction is? And that's what we believe is whenever we're characterizing friction for safety performance modeling, we want to look for the low friction, as that may be playing a role in any crash risk out there. So again, it's just very challenging to do a trailered unit. And even if you do, and you have a discrete measurement system, are you really going to characterize friction at this location to the point that we need for safety analysis modeling? All right. So let's go back to kind of this discussion about what is an appropriate analysis segment length for the safety folks to use whenever they have friction available to them. Essentially, with the data I showed you, hopefully you see that friction can vary, and it can vary fairly significantly over a short length of space. And so what we believe right now is maybe the appropriate length for this analysis would be 1/10 of a mile. And that's heavily driven based on the location of the crash, the confidence in that crash location data. One thing I want to really highlight also is just because you have low friction, I'm not suggesting that you automatically invest in a treatment. We use the term investigatory friction thresholds, and we try to be clear it's about an investigation. What we would suggest is maybe an investigation would occur to see if the friction may be playing a role in crash risk. All right, so let's look at one final example of data, and we're going to go into an urban setting here. Again, we've got continuous pavement friction here. And as you can see in the overhead photo, we have one intersection here, and we have another intersection here, and then we have a ramp onto an overhead pass here, overhead roadway. So we have a lot of different vehicle characteristics going on at this location. And what we did is we did continuous friction data here. We did the safety analysis modeling, and we recommended to this agency to investigate several locations and see if maybe friction would be playing a role in some of their crashes. This agency are very familiar with road safety audits. Road safety audit is an on-site investigation where you have a multidisciplinary group. They always try to include law enforcement, pedestrian, bicyclist, traffic signal, safety specialists, pavement, materials, maintenance folks. They try to bring all the designers and everybody together, go on site and assess what is going on here, because this is a higher crash location area. Are there things that we could do to try to improve safety at this location. So what was unique is we had continuous friction data through this location. And here's what we see. All right. Hopefully you're familiar with this graph. Again, on the left-hand side, you can see this is the coefficient of friction. And you can see this is the same friction measuring system from the other data. And you can see it varies as you go along the roadway. And on the right-hand side, we have the macro texture mean profile depth. Again, the red line shows you that it will vary at locations. We're going to focus in, the intersections I showed you were in this 12.5, 12.6 area here. And you can see both the friction is dropping and also the macro texture is reduced in this area here. And if you remember the macro texture measurements from that other case study, you saw that normally it was above 1 and would sometimes drop to about 0.7. So let's look a little bit closer at this. As we approach the intersection, we have an asphalt pavement surface, and the asphalt pavement surface that you see that I'm trying to highlight with my pointer is all the same exact asphalt material placed the same time, same mix, same construction contract, probably placed on the same day. So it was run through the intersection. So I want to highlight again, it's the same asphalt pavement surface. As we approach this intersection, on the right-hand side, you can see that we have a bus stop here. There is a slight downgrade at this intersection, so there could be a minor sight distance that comes into play, which may create folks needing to brake a little bit quicker than what they would normally do with proper sight distance. But you can see at this location here, our friction is at 44, and our macro texture mean profile depth is at 0.34. Now, we're just going to go a few feet forward, and we're going to go to the other side of the intersection. And look at how the friction here is now about 54, and the macro texture is 0.7. Again, exactly the same pavement surface, mix, contractor, everything. The only difference is that the tire interactions have created a change in both the micro texture and the macro texture. And now we're going to go on to the next section of pavement, which is on some concrete pavement. And you will see again that the friction changes to 39 and the macro texture is 0.28. Again, with continuous friction data, you're able to see these changes, which can occur at a very high resolution. So the collection of continuous friction along with macro texture, again, you need both an indication of the micro texture and the macro texture. We believe it needs to be continuously measured for the safety performance modeling and analysis. And there are many more factors involved than just the micro and the macro. The roadway geometry plays a key role in safety performance, but all of these pieces of information come together in safety performance modeling and analysis to give us an idea of the crash risk. So with that, that is all of my presentation. Thank you.
Thanks, Andy. Very informative presentation. I have a couple questions for you. First question is there any guidance for the safety discipline to factor in maintenance costs or service life in the benefit cost analysis? For example, high friction surface treatments have shorter service life in climates with snow, ice, studded tire, and chain wear.
Okay, so whenever the costs are derived, the costs are just like you talked about there. They are the cost of the installation, the life of the installation, whether or not you have to go and do additional treatments and such. So that can be all part of the cost in the cost benefit analysis. So I guess what I'm saying is that that's part of the equation if you decide to factor that in.
Okay, and before I ask the next question, a reminder, you can type in the chat pod or you can raise your hand if you have questions. So I have a couple more here for you, Andy. Is the accident location where the vehicle initially loses control, where it leaves the lane, or where it comes to rest at the end of the event?
So the safety folks have informed me again, the accident location is identified by law enforcement. And so we have a wide variety of law enforcement officials out there on the roadway, so you have variability there. They could be using GPS and different instrumentation of mile points. And it is up to the discretion of that law enforcement official where they identify the location where they departed. So again, there's variability there. It could be where the vehicle is at rest. It could be where the law enforcement official believes the vehicle left. So there is variability in that. That's why that the safety engineers say that really the location, we have confidence within 1/10 of a mile, but probably not in a location any shorter than that. So there is variability.
Okay, great. And I'm going to come back and say to the previous question, Jeff Shaw just added a comment to the previous question. Yes, there is guidance within the safety discipline about how to do a benefit cost, a BCR analysis, benefit cost ratio analysis that takes into account different life cycles. I do have a couple more questions, Andy. Hang on.
Yeah, let me touch base on one thing that we in Pavement and Materials may not think about as much as the safety community does on these analysis. Not all the time is the issue polishing of the pavement. It can be the roadway geometrics are so challenging that even with your normal asphalt pavement in good condition, the friction is not enough because of the roadway geometric challenge. And so that's where the safety folks will look at it. They'll look at the cost to reconstruct that curve, the cost to do pavement enhancements, cross slopes. So they look at all those different options, and that's where maybe they will come down and the benefit cost ratio will show that a high friction surface treatment would be potentially the best benefit cost ratio at that location, because you can imagine the cost to reconstruct curves is very great compared to a high friction surface treatment installation. So I want to highlight that to the pavement and materials community is don't always think it's polishing of the pavement that causes a situation. It could be the roadway geometrics just are not able to handle that.
Okay, thanks, Andy. Do the non-contact texture measurement techniques distinguish between positive and negative texture? The difference is important to friction measurement.
Absolutely. So I tried to be careful whenever I talked about macro texture, and I indicated that the mean profile depth is the measures that I showed you. There are many different measures of macro texture, and just like the individual making the comment, there is a difference between negative texture and positive texture. So negative texture would be like on an open graded friction course, and positive texture would be on such an item such as a chip seal. There is a difference in that. So there's research that is needed in what are the best macro texture measurements that give us insight into friction characteristics. But I haven't seen that research, so I believe that is more of a research need than what is known at this time. So there is no perfect macro texture measurement. There is no perfect micro texture measurement at this time that I'm aware of that relates directly to friction characteristics.
Okay, great message that we pavement engineers need to understand how what we do is used by safety analysts. The analogy of drilling crew for bridge and pavement foundation is spot on. How often has pavement friction been the primary contributor to a crash?
If I could have my safety engineer, Mr. Shaw, I would prefer a safety engineer respond to that. Hopefully he's on now.
Sure, Jeff. Would you like to unmute yourself and speak up?
Yeah, I'm still here, guys. I'm trying to find that question in the thread. Jennifer, can you read that again?
Yeah, sure. How often does pavement friction, how often has it been the primary contributor to a crash?
Oh, okay. Well, I'm not sure we know the answer to that yet. So one of the things about our experience with high friction surface treatment, for example, we rely a lot on surrogate methods like a wet pavement cluster of crashes, or the ratio of wet crashes to the total number of crashes. And that's usually the way that we would find locations that might be responsive to a high friction treatment. I think the work that we're doing with Andy and the pavements team should shed some light on just to what degree is friction a significant variable in determining the safety performance of a roadway. So right now, I don't think we can answer that question, but if we look to some of the international experience that Andy had alluded to in his presentation, it could be anywhere from a 20 to as much as 60% difference in crashes based on the friction conditions. So it obviously depends on whether we're talking about a curve or a segment and a freeway versus a 2-lane rural, but a significant percentage of crashes could be partially due at least to friction.
Great, thank you. Thanks for your input, Jeff. What's the cost of the continuous friction measurement device featured in the presentation? Is it commercially produced by multiple manufacturers? Is there a standard for the equipment testing, ASTM or AASHTO yet?
So there are many continuous friction measuring systems in the marketplace. Our sister transport agency, FAA, their standard is continuous friction measuring systems. So there are many different continuous friction measuring systems that are available out there. The one that I showed you, we purchased specifically for a friction project where we were looking to measure thousands of miles, and it had a robust history. So that device has been around, manufactured in service for over 30 years in the international community. There's an AASHTO standard that will be published in 2021 for those interested. It is commercially available. There are multiple manufacturers. Again, there's, cost really depends upon what are the different attributes you want the system to do. So it's highly variable, and they're made per request. So there's not a stockpile of these systems, just like the traffic speed deflectometer. There's not a stockpile of those systems out there. It is specialized field testing equipment.
Okay, great, thanks. Andy, we had a lot of great questions. If it's okay with you, can we keep going? We're at 3:30.
That's fine with me. It's
okay.
Whatever works for you
okay,
guys.
we have a few more. I'm first going to mention there is a survey that, the link, it's going to be posted in the website. If you have to step off, we're going to ask that you fill out the survey. It's real short, just a couple questions. In the meantime, I'm going to there's about 3 more questions for you, Andy, if we can get through them. Do you anticipate continuous friction measurement to become the standard? And if so, how far in the future do you see that happening?
So again, the technology exists. So whenever an agency is wanting to do that, they could do that. One of the key things is you have to make a business decision. What is it you need from a safety perspective? There may not be a need to do network level friction testing, or there may be a need, but again, that's all agency specific. I can't comment on that. But if you're doing an investigation and friction is part of that investigation, I just see that it has to be a continuous friction assessment, because friction does vary. And so using a discrete measurement system is, based on all the data that I've seen, is just not going to give you all of the information you need. A discrete measurement system is going to go through that process of, you're going to get some false positives. No, you're not going to get a false positive. You're going to get a false negative, and you're going to get true positives. but you're not going to be able to understand all the friction through there. But again, if you're looking at a location that was identified based on crashes and roadway geometrics, let's talk about Kentucky. As I mentioned, their high friction surface treatment installations were not based on friction measurement. They were based on other attributes, again, which is what happens commonly in safety analysis. If you're looking to assess friction at those locations, I would believe you would need to use a continuous friction measuring system at that location and really profile the friction to see whether or not it would have a major contributing factor, potentially major contributing factor. Hopefully that answers the question.
Thanks. How about environmental limits to perform testing? For continuous friction, are there any requirements? Can you run it when it rains or snows?
So anytime you're placing water on the roadway, you want to do that in an environment that will not create a hazard. So again, it is highly weather dependent. The thickness of the water film, because we are applying water directly in front of the rubber tire, it is a certain quantity of water that we place there. So you would prefer to have a pavement that is fairly dry, or a little bit of moistness is not going to impact it too much, but you definitely don't want to be out there in the middle of a rain event. And just kind of a side note is, if your friction measuring system also has the laser-based macro texture measurement, then you need a fairly dry piece of pavement to use that system on. So in general, you really want to be in a fairly dry environment without a freezing event happening.
Thanks. And the last question that I see for now, for evaluating a set of materials for a JMF screening for low friction characteristics, what type of tests would you recommend to screen out suspect mixes?
I'll just talk on one of the issues there, and that is macro texture. Macro texture is important. Hopefully you all remember what macro texture is. It is a void on the surface. And if you're talking about a job mix formula, then most likely you're talking about a hot mix asphalt, which would have a negative texture. So you're not talking about a chip seal. So I believe that you want to assess macro texture. There are devices out there that can measure macro texture on a gyratory sample. And we have work going on at Federal Highway Administration to try and develop a standard test procedure for agencies to use in measuring macro texture. One of the key things you have to then find out is, what is the needed macro texture out on your roadway? There are many factors involved in that, so there is no one number to answer that, and that's really where you need to bring in your safety engineers to perform that safety analysis and modeling to give you an idea of what is the appropriate macro texture from a safety perspective. So it is job mix formula, macro texture. Those are all things that we can do now. There's a lot of work that needs to occur at the local agencies to figure out what is an appropriate level of macro texture.
Great, thanks. I think I covered all the questions in the chat pod. Hopefully I did, and I didn't miss any of them. I am going to turn it over to Heather for some closing remarks.
There's one more, Andy. Maybe you can answer Life's question that just popped up through the chat. But we'll wrap up. So thank you all again for attending. Like Jen mentioned, there's a survey that we had posted for you to fill out to provide any feedback on the webinar series. Again, if you want PDHs or copies of this presentation slides, be sure to fill out the last question with your email address. I have already sent out the first two webinar series copies of slides and PDHs. So if you didn't get one of those, that may mean that we don't have your email address. So you want to contact me in that case. Also, Sharon is going to post in the chat box soon the listserv link. I hope, and by next year, early next year, we'll have our newsletter to distribute the information, and I don't have to keep track of everybody's email addresses. So hopefully announcements of the future webinar series will be on the Pavement and Materials official newsletter. So please be on the lookout for that. And Sharon, if you could post that in the chat pod, that link, that way everybody making sure they have signed up onto our listserv and will be getting the latest to date information. I think it came in highlighted, Sharon, I'm not sure, but it is active. If you just highlight it and copy it, it should work. With that, happy holidays, and hopefully see you around next year. Take care.